Temperature and humidity display. DHT11 is a basic, low-cost and digital temperature and humidity sensor that can be interfaced with any microcontroller, like Arduino, Raspberry Pi etc., and we can achieve instant results in digital output. In this project, we will interface DHT11, humidity and temperature sensor, and LCD display, with the Arduino. This humidity and temperature sensor provides high reliability and long-term stability. DHT11 humidity and temperature sensor makes it easier to add moisture and read temperature data to any electronics projects. It is a perfect solution for remote weather stations, home environmental control systems, and farm or garden monitoring systems, etc. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5V. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. DHT11 sensor has 3 pins, 5V, ground, and output. 5V pin of sensor is connected with the 5V pin of Arduino. Ground pin of sensor is connected with the ground pin of Arduino. Output pin is connected with the 0 pin of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line, #include liquid crystal.h. Now we will include the library of DHT11 sensor. To include the library, we will write in the next line, #include DHT.h. Output pin of the sensor is connected with pin A0 of Arduino. Then we will declare the name of the used pins, in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. Void setup is a function in which we have initialized the LCD. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. DHT.read11 DHT a pin. It will read the value of the sensor connected at pin A0 of Arduino. LCD print DHT.temperature. It will print the reading of temperature on the LCD display. LCD set cursor 0,1. It will print the message in the next line on the LCD display. LCD print DHT.humidity. It will print the reading of humidity on the LCD display. This function will print the message, written inside the brackets, on the LCD screen. Delay 1000. This function will generate a 1 second of delay. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red, and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1, and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4, and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5-volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect a red wire at VCC pin, black wire at ground pin, and a yellow wire at output pin of the sensor. Now connect the red wire with 5-volt pin of Arduino, black wire at ground pin, and yellow wire at A0 pin of Arduino. Now we will power up our project and test its functionality. We will now use a matchstick to increase the surrounding temperature of the sensor. We can see that the temperature and humidity reading is changing on the screen. Our project is working perfectly. I hope you enjoyed the video and learned something from it. For any help in your project or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.